Welcome and thank you for joining us for our virtual maths workshop. Whatever stage or level your own personal mathematical comprehension is at, we hope that we can deliver some valuable information in this workshop. By the end of this workshop, we aim to have given you a clear understanding of what early mathematics looks like and share the mathematical input and experiences your child will have during their reception year at Redlands. We will explain the mathematical concepts covered in the early years and what we expect your child to have learned by the end of the year. By engaging in this workshop, you will be in a great position to support your child as they learn to develop these skills, working in partnership with us to support your child as they continue to build on their mathematical foundations. In this workshop, we will cover why is maths so important, how we teach maths at Redlands, the early learning goal and the exceeding for number and the shape, space and measure aspects of the curriculum. Aspects of the mathematical curriculum, including cardinality and counting, comparison, composition, pattern, shape and space and measure. And we'll encourage you with some ideas on how you can support your child at home. So why is maths so important? Maths is everywhere in the world around us. Children will need to be able to use and apply maths in everyday life. Maths enables children to think logically and to problem solve. How we teach maths. At Redlands, maths is taught in a variety of approaches. Adult-led sessions are sessions that take place in smaller family groups or in whole class. They deliver the curriculum coverage. They can be differentiated to the needs of the children in the group in the moment, and they will be consolidated and extended within children's play at other times. We deliver mathematical opportunities through enhancements in children's play. Within the environment, there's scope for maths within the continuous provision. By setting up mathematical activities for children to explore independently, it's a great way to reinforce concepts during their free flow time. Every time maths is built into an everyday activity, it helps to embed and reinforce understanding of concepts. For example, we have numbered bikes with matching numerals and numicon pieces so that when they come to park them up, they can match the numeral to the correct piece. We have labelled pen pots with numicon stickers to help children support their counting at tidy up time and count the correct number of pencils and pens into the pots. There are mathematical rules that we can set, such as perhaps allowing only 3 children to play in the sand at one time, and this can lead to opportunities for discussions, such as how many are there now, would there be room for one more, or are there enough space for each child to play? Within the children's play, adults act as play partners. They carefully engineer opportunities to develop children's mathematical skills by targeting individuals during their playtime. For example, they might suggest an activity like laying the table for the teddy bears in the home corner. This will help children to start to problem solve and think about the number of items they would need, whether we have enough or whether they need to go and get some more. This reinforces concepts such as one more and one less or difference. It might help the children to think about sharing or naturally dividing during the activity. In this clever way, learning can be disguised as play and the children will naturally enjoy the activities that they're set to do by the adults.
So, tell me about it, Stan. What have you got?
Pen and brick.
And what does that make?
13.
Okay, can you make me any other numbers and tell me about them?
Okay.
So what can you tell me about this one?
It's 2 and 12.
Okay, what is it all together?
14.
Okay, can you show me it as a 12? Can you show me how you make 12?
I haven't got a 2 though.
Oh. Are they on the board? Are they on here?
Well, there are pictures of numbers.
Okay, we can use that.
Yeah.
That's fine. So what does this one mean? How many?
10.
And
2.
so all together,
12.
are you going to show me any more?
Yeah.
Which ones? Tell me what you can tell me so that I can see it too.
The early years curriculum is divided into two main areas. The first one being number and the second one being shape, space and measure. First of all, we're going to look at number. The early learning goal for number is that children can count reliably with numbers from 1 to 20, place them in order, and say which number is one more or less than a given number. Using quantities and objects, they can add and subtract two single-digit numbers and count on or back to find the answer. They solve problems, including doubling, halving, and sharing. For children to achieve the exceeding statement in number, they must be confident to solve problems using their knowledge of counting in 2s, 5s, and 10s. They must be confident estimators and focus on the application of number and knowledge in problem solving. Now we are going to look in more detail at aspects of the mathematical curriculum, starting with cardinality and counting. With cardinality, children need to have an understanding of the cardinal value of a number. This refers to the quantity or how manyness of things it represents. There are a range of skills in counting your child will need to understand and become secure in. Saying number words in sequence, for example, such as counting to 20, counting back from 20 in ones, counting in 2s to 20 and back, counting in 10s to 100 and back, counting in 5s to 50 and back. Being able to count on and back to solve problems.
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Woohoo! Check it out.
Other counting skills that the children must develop, aside from rote counting, is the idea of one-to-one correspondence. Firstly, by moving objects. Moving on to the skill of one-to-one correspondence by touch counting. This is counting things that can't be moved. It may be counting items in a picture or counting the number of claps or jumps that has been done. They also need to begin to recognise amounts. Number songs can be a great way of helping children to learn counting. Counting rhymes and books and songs help children to develop their understanding of number and counting and remember the patterns that are involved. Now let's look at mathematical skills to support cardinality in counting. Using concrete resources in maths comes naturally in EYFS. Being able to touch, feel and manipulate the maths is an ideal way to help children develop an understanding of the underlying concepts. Subitizing is the skill of being able to recognise small quantities without needing to count them all. We use questioning. Questions you can ask such as, how many eyes or legs are there? How many would we have if we had one more? How many would we have if we had one less? How many would we have if we had double? Or how many would we have if we had half? Children also need to develop an understanding of the value of number. This is the numeral meaning. A oneness of 1, the two-ness of 2. This is like having a clear knowledge of each number, how each number is made up, what it looks like, and how the parts of it can be moved but still remain the same. They also need to develop their understanding of place value. This is the value of each place of the numeral in the number. So as the numbers begin to grow beyond the number 10, they begin to have a tens and ones category, which are two-digit numbers. So for example, in the images, you can see how the numicon plates represent the quantity, the value of the tens. This gives the children the concrete understanding of how place value works with two-digit numbers and beyond. Understanding the concrete value of a number and retaining that visualisation of the quantity in the mind's eye must be secure before children can move on to pictorial and formal representations of mathematics. Otherwise, they'll struggle to give reasons to their understanding in that abstract form, to be able to predict or identify when something doesn't look quite as expected. This is why using concrete resources and undertaking practical maths is the main focus for children in the early years. We encourage and teach them complementary and age-appropriate recording methods alongside the practical maths, so they can begin to record what they have understood, such as informal jottings or marks to represent amounts. To help the children begin to understand the more abstract version of maths, we might start with moving from representation with a clear link, such as using toy versions of the animals, to representation with something less obviously linked, such as counters and the part-whole model. This ensures children develop an understanding of representation, building a firm foundation for later success in maths. Children will need to learn number conversion. We can see this in the example of the part-whole model, knowing that the number does not change if things are rearranged. Here, we will show you how the number 6 can be explored and find different ways of using the part-whole model to see how the number 6 is composed. There are some really fun ways to teach children about number formation. At Redlands, we like to teach the children using number rhymes. This supports the recall and recognition of the numerals to represent the quantity. For example, here we have the number 5. Our rhyme for the number 5 is short neck and tummy fat. Number 5 wears a hat. You should have received all the number formation rhymes in your initial induction packs. If you do not have this at home, please mention this to a member of staff and we will copy you another one. Children will need to learn the more than and less than language that links to quantities and be able to use this when comparing the quantities to describe whether the quantity has more or less than another one. They will also need to identify the groups with the same number of things. Here we have an example of a challenge where you are being asked to compare two unequal groups and solve it so that the two groups have the same number. Here you may pause the video and consider or even act out how you would solve this problem, or you may continue to watch to see how one of our EYFS practitioners might solve the problem. When undertaking mathematical challenges like this example that asks them to compare the numbers, it is important alongside its exploration to encourage children to reason how they know and not just accept the correct answer. Ask them to prove it. Can you show me another way? We are now going to move on to discussing composition. Here we have a clip of a part-whole model being used and the teacher using it to support addition and subtraction. Part-whole model is a fantastic teaching tool to help children not only understand the numerical value, but also to explore the numerical arrangement of that value. Here the whole number is split into two parts. When the parts are put together, they create a whole. This concept of partitioning of a number is representation of addition and subtraction in the early form. Addition and subtraction can be explored when looking at composition. Children will need to partition numbers and be able to put them back together again. This underpins the understanding of addition and subtraction as inverse operations. Other really good examples of ways of helping to teach children about addition and subtraction can be through the use of number songs, perhaps playing skittles, identifying the whole and then determining how many are standing and how many have fallen. We also use the bar model, 100 squares and number lines, and by exploring composition, children are able to learn their number bonds. Number bonds are learning the pairs of numbers that add together to make one total.
Can you find a number that is bigger than 9, Max? Oh, what number do you have? 10! 10 is more than 9. And it goes down. Wow, it's not balancing, Logan, because 10 is more than 9. I wonder, Logan, can you make this one 10 as well? I've got 9. How can I make it into 10, do you think? Oh, put it in there. Let's see if we can balance it this time. Is it going to balance? Is it going to balance? Well done!
Let's look at how we might go about exploring number bonds to 5. We may use examples like 5 toys go into a tent and then 2 come out. How many are left in the tent? This challenge expects the children to be able to know they need 5 objects to represent the 5 toys going into the tent, and then they need to partition the number so that 2 of them come out. In doing this, they are making 2 parts from the whole. They have also undertaken a subtraction problem. We will explore number bonds within addition and subtraction and show the children how they are inverse operations of one another, and that they link nicely to the number bond knowledge learnt with the part-whole model. Within mathematics, there is a vast array of mathematical vocabulary that the children need to learn. For example, we might use the words take away, subtract, or minus, less, or how many are left, or we may use add, plus, or how many altogether when discussing addition and subtraction. The children need to become familiar with all of this vocabulary, so it's important that it is used interchangeably and that the children become familiar with it in the context of the activity that they're doing. Here we have a new challenge. Tilly the T-Rex laid 12 brown lumpy eggs. The next day she laid 18 more. How many eggs are there altogether? With this new challenge, we need to think, what do we need to know to solve this problem? If you were doing this with your child, what could you use to help? When rereading the question, we know that we need to pick out the important information and discard the irrelevant information. Here, with Tilly the T-Rex, we can see that she has laid 12 eggs and 18 more the next time. How many eggs are there altogether? 12 and 18 and the word altogether help us to know this is going to be an addition problem. We know that in the early years it's really important to use concrete objects. So you might fetch some representative eggs or something more abstract like counters or other objects that can help you. From experience, we have also learnt it is easier to count on from the larger number. So in this situation, we would take the number 18, which is the greater number, and count on from that number. Another strategy might be to take the 2 numbers and partition them into their 10s and 1s. If you use Numicon for this, and the Numicon plates, you would be able to lay the 2 10s from the 12 and the 18 together, and then you would be able to lay the number 8 and 2 plate together to see that 8 and 2 are number bonds to 10. Therefore, when you put them all together, you would see we have the equal of 3 lots of 10, which would be the number 30. If we give the children practical objects to help them to prove what they have understood about the problem, then we can support them to use the correct vocabulary and be able to describe their understanding. Solving a problem mentally and using their knowledge of place value and number bonds is fine, but it's important to ask children to prove how they have done it and explain how they know that they have got the correct answer. If we give the children practical objects to help them to prove what they have understood about the problem, then we can support them to use the correct vocabulary and be able to describe their understanding. Solving a problem mentally and using their knowledge of place value and number bonds is fine, but it's important to ask children to prove how they have done it and explain how they know that they have got the correct answer. We have now explored the number side of the curriculum together. Next, we are going to be looking at the other side of the mathematical curriculum in the early years, which is shape, space and measure. Let's look at the early learning goal for shape, space and measure. Children use everyday language to talk about the size, weight, capacity, position, distance, time and money to compare quantities and objects and to solve problems. They recognise, create and describe patterns. They explore characteristics of everyday objects and shapes and use mathematical language to describe them. To be able to obtain exceeding, the children must be able to estimate, measure, weigh and compare, and order objects, and talk about properties, position, and time in a confident and detailed way. A huge part of the shape, space, and measure side of the curriculum is extensively language-based. We need to teach children not only to understand the language for shape, space, and measure, but also to be able to use it. This may start with comparative language for objects and their size, for example, the smallest, small, medium, larger, largest. Or it may be comparing weight, such as heaviest, heavy, heavier, lighter, lightest, and so on. There is so much comparative language. When talking about size, it might be between the language of big and small, or it might be to do with length, such as longest, shortest. It might be to do with weight, such as heavier, lightest, or capacity, holds more and holds less, full, half full, empty. The more children explore and play with these concepts, and the more they practice using the vocabulary in their play, the more the concrete understanding of these becomes, and the more fluent the children will become at using them. Children will also need to develop positional language. We can encourage this through positional games. It might be directing a friend from one obstacle to another. It might be that we hide a toy and the children have to find it and describe where they found it. We would model the language first and encourage the children to use it when describing where they found the object. We might get them to do this in pairs for one another, as extending the play and doing it in this way is much more fun playing with a friend. We sometimes use stories that involve positional language. Going on a bear hunt is a great one. Going through, under, over, around. Sometimes children struggle with behind, underneath or in between. So it is worth practicing these ones at home. When learning about shape, children will be playing with and making arrangements with different shapes. We usually teach the 2D shapes through teaching 3D shapes, so exploring the 2D shapes and their properties whilst also teaching the 3D shape alongside, so that the children become familiar with the two. This is often because in real life there are not that many 2D shapes, and actually most things are made up of 3D models whereby you see a 2D face. Children also need to know the language that goes along with 2D shapes and 3D shapes so they can describe them, such as flat, solid, corners, sides, edges, faces, and so on. It makes sense really to explore 3D and 2D shapes through the use of real and everyday objects, because in reality this is where the learning is most purposeful, where it has meaning and makes sense in the real world around us. Children will learn about patterns. We look at this through the patterns of everyday objects. We also teach children about repeating patterns. It may start off simple with a set, for example, a this and that type of pattern. For example, the A, B repeat. As children become more confident with this, they might be challenged to look at ABC patterns, where the repeat is ABC, ABC, or even further, ABBC, ABBC. This is where we have a set sequence and it repeats. Alongside this, we might expect children to extend the pattern, work out what comes next, or fill in the missing gap. When looking at measures, it's best that the provision is designed so that children can explore the properties of objects, where they can weigh and measure, such as a cookery station or a building area. They may have small weighing scales and outside larger ones with buckets. They also explore measures when playing in the water tray or in the sand area, as they will naturally be looking at capacity and how much something holds. We like to offer the children regular opportunities to measure in real life contexts, such as cooking and baking. This is a lovely activity that you can do together at home, where the children will be able to help towards preparing for dinners or baking special treats for the family. Children really love to get involved and learn so much better when they are actively participating and enjoying the play.
Is it level now, Max? Oh, it is. Okay then, Max. What's the answer to the question? How many beads are equal to the bird?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 18, 19, 20.
So 20 beads are equal to the bird. They're the same. Well done. Nice challenge.
To finalise, we thought we might put together a few ideas on how to support your children at home. As you know, maths is all around us in everything we do. We can engage children to develop mathematical concepts in simple ways outside of school that support the normal running of a home, and it makes it easy. Just invite your child to help. When out and about, why not look at the numbers in our environment, such as on the doors or car registration plates, people's telephone numbers, and the prices on tickets. Children always benefit from counting practice, and they enjoy singing the number songs they've been learning at school with you at home. You could look at sorting together, perhaps sorting into sets, such as sorting the cutlery before it's put away, sorting the beads, the buttons or counters by colour. You could ask your children to help at dinner time by laying places at the table, counting the places and the cutlery and seeing if they have enough for everybody who's going to be eating dinner together. When sharing books with your children, use the pictures as opportunities to develop mathematical understanding, such as how many people can you see in the picture? If each person has 2 legs, how many legs are there in the picture? I wonder how many more there will be if 2 more people came along. Play alongside your child, such as in the sand or the water tray. Provide them with different variety-sized containers. Your child may even notice some containers have got measures written on the side of them, which you can discuss and explain why we use them and how they help us. Your child could help you by weighing ingredients when cooking. They might like to help you sorting money. Children love using real coins. This will also help them look in detail at the different types of coins that are in our money system, recognising them by size and colour and shape. You can also draw their attention to the value and make comparisons of their value by comparing how many pennies each one is worth. Try playing some of the games where you expect your children to use positional language. Hearing it as often as possible and understanding the concept will help children to be able to use it, such as, can you put the cups in the cupboard? Practice number formation with your children by reinforcing the number rhymes that we have taught the children at school and sent home. They might like to do this in the mud or sand with sticks. They might like to do this by finger painting or rainbow numbers. Children love family games and they can be great at reinforcing practical maths such as counting, for example in snakes and ladders. Keep reinforcing that comparative language we've discussed, such as which is longest or tallest, for example. Thank you for taking the time to listen to our workshop. We appreciate that over the years, maths is maths and has not really changed. However, the way that we support children to learn it has developed over time. And so we hope that you've been able to learn something new through our workshop today. Thank you.